Two British paleobiologists are reasserting Earth's uniqueness in the universe as a living planet, even while the search for life elsewhere in the cosmos has gained great urgency in recent years. Jan Zalasiewicz and Mark Williams, both professors of paleobiology at the University of Leicester in the United Kingdom, are challenging the growing tendency to dismiss Earth as just another minor planet orbiting a mediocre star in a garden variety solar system. In their richly detailed book, The Cosmic Oasis, the remarkable story of Earth's biosphere, they examine Earth's biosphere to make their case of its cosmic status so far as the only place where such a rich diversity of life exists. The biosphere is essentially the thin skin of a few kilometers above Earth's surface and barely 4 kilometers into ocean depths that surrounds our planet. Everything that we call life has unfolded in this stratum. So far, NASA has discovered close to 5,500 exoplanets, but none with any discernible signs of life as we understand it. To explain why they think our planet is a cosmic oasis, Dr. Zalasiewicz and Dr. Williams spoke to my Shire Reports. Early on in your book, you seem to be challenging the view that in the cosmic context, Earth is but a small planet orbiting a mediocre star around a garden variety in a garden variety solar system, rather.
Um, yes, Mike. I mean, we wanted to kind of get away from the premise, which is really beginning with Copernicus, I guess, that the Earth is a kind of obscure planet in an obscure solar system in a relatively typical kind of galaxy amongst billions of galaxies in the universe. And we wanted to argue for the centrality of planet Earth, which is really why Jan and I chose the title The Cosmic Oasis, because as far as we know, it's the only habitable planet in the entire universe, and therefore it still has a kind of central purpose in terms of questions about habitability and the questions of how precious this planet is in terms of its complex biosphere. So we were trying to put the Earth back in the centrality of the cosmos from that perspective.
Yes, I think very, very much so, because I think we're all of us brought up, on science fiction, with astronauts going to other planets and meeting other life forms, and whether it's Star Trek or Doctor Who, or even if you go back in serious literature a little while back. Then most of the major scientists, thought, as you said at the beginning, that the Earth was really not anything special, and that we would expect to see, living planets widely once we started to look properly. But now we are looking properly, with the help of the spacecraft that go to the edges of the solar system, and the James Webb Telescope. It shows that both the solar system is very different from most other star systems, and nothing like the Earth has yet been found, not remotely yet. So in a way, as you said, there is if you like, at least a biological centrality, to our planet.
Do you then run the risk of becoming, if not anthropocentric altogether, Earth-centric?
I don't think so. I mean, just to add to what Jan has just said, we've been searching for extraterrestrial intelligence, for example, for the past 60 years, since the SETI program developed in the 1960s, and we haven't found any evidence out there whatsoever for biospheres like our own that have become sentient and able to contemplate the universe. So I think the kind of central importance of Earth and of its biosphere is the fact that it's existed for 4 billion years. It takes that huge amount of time to develop the level of complexity that we've got, and indeed to develop an organism that's able to contemplate that complexity. And then into that context, you throw in the fact that organism is also capable of doing quite a lot of destruction to that biosphere. And again, I think that brings back, to the central point of just what a jewel planet Earth is really in the cosmos.
Yes, I think it's, Mark's quite right to distinguish the if you like, the biocentric view from the anthropocentric, because for more than 3 billion years, Earth has been a living planet, well before humans arrived, and for the last 500 million years, there have been many complex multicellular organisms, from trilobites, to fish, to dinosaurs, to cats and dogs and elephants, all of which are sentient creatures and part of this biosphere. And I think that has always, we know has been special. And humans have come along and, as Mark said, have added, have altered the nature of life quite remarkably in quite a short space of time.
Do you then fear that our quest for life elsewhere may be somewhat overstated, exaggerated, or it may be dimming at this stage?
I think that's an important scientific debate, and and as a species that wants to contemplate the cosmos, that's an obvious question that we're going to ask, and it's good that we're looking, and we've got various different ways of doing that. But I think what worries me, and I think what worries Jan, is that has sometimes blindsided us to thinking about how special our own planet is. I mean, even if we are to find biospheres on other planets, in other parts of the universe, the chances of them being as sophisticated and as complex as the one that we have on planet Earth are probably quite low. There may be many biospheres out there, but they may have, they may have stayed in a microbial state. They may not have got to this level of complexity. So I think, we all grew up on those starships whizzing around the universe, meeting lots of complex organisms, yes. and I think that may be a rather distant view of what the universe is really like.
Yes, Mark's perfectly correct there. I mean, there may be life out there, perhaps even on Mars. Somewhere, deep below the surface of the planet, where there might be some liquid water, there may be small populations of microbes out there. There are small, faint hints, in little bursts of methane, which may be biological or may not be. But years ago, the scientist James Lovelock, made the really important point that Mars is functionally dead. It is behaving, according to the laws of physics and chemistry, whereas Earth, is very much controlled. Its climate, surface conditions, all, even as far as its geology, is to a large extent controlled by life. So it's a huge distinction. And this kind of living planet, truly living planet, as Mark said, is, as far as we know now, is terribly rare. Now having a much larger sample of planets to compare with.
The reassertion of Earth's primacy has profound philosophical implications. And you are in the community where everything is challenged. Are you getting any pushback from your fellow scientists about this view?
I would say yes, indeed. Certainly, the centrality of Earth, and also I think the centrality of human action on Earth, more to the point, I think, is where there's been a good deal of pushback, because that's much more of, if you like, an uncomfortable position, to come to terms with. I think the idea of the Earth as being a rare biological jewel, is less uncomfortable. No less remarkable, but less uncomfortable. So I think that is more widely, accepted now.
I think there are some uncomfortable discussions also around the amount of energy and resources that you need to utilize from planet Earth to actually go out and explore space. And I mean, the irony of that is that, that you could actually do damage to your own biosphere in the hunt to look for life elsewhere. And I think there's a very interesting and nuanced argument around that, around us just remembering how special the place is that we live on. And, arguments around colonizing Mars, for example, or as Jan said, we don't even know if there is a biosphere there or not. And if there is a biosphere there, then there are really strong moral questions which, take us back to decisions that were made in the past when colonial powers tried to colonize other countries. There's a big moral discussion around that, because we might do serious damage to Mars if we went there. But even beyond that, it's interesting to think, of the kind of biomes on Mars that NASA have been talking about, and other space agencies, and the way in which those biomes have to absolutely recycle everything, the water, the air. They have to be self-sustaining in terms of the food supply. And yet on planet Earth, we don't seem to give a damn about that. We're quite happy to use resources in a manner which is completely unsustainable in a very short time frame. And I think that's where the really big nuances in this argument are, and where we do need a much bigger discussion about this.
The biosphere is essentially a very thin skin in the context of Earth's overall size. You're talking maybe a few kilometers above the surface and about 4 kilometers in the ocean depth if you take the average depth. Or if you go to the deepest point, which is, I think, the Challenger Deep, about 10 kilometers or so. So it's a very thin layer. And yet, everything that has happened on this planet is within that thin strip. I'm quite fascinated by that view. Tell me a bit more about when you approached this book. I'm interested to know that.
Well, I think you're quite right. I mean, the scale of the biosphere. As I say, it's we think of the Earth as a planet, and we see it, and we see these pictures, but it is that terribly thin skin that is not simply living, but is controlling much that is non-living there. Perhaps even going as far as controlling the nature of mountain building and plate tectonics, the pattern of earthquakes and the pattern of volcanism on Earth. In that, and this scale of what's been called the critical zone, I think is a really important jumping off point from that. So it's not an artist have tried to find ways of, if you like, looking at the Earth inside out to try and bring us new perspectives, to break us out of our feeling of, if you like, of taking all of this for granted. It's a remarkable machine, and if you like, it's a paradox. The Earth is habitable because it has this, living skin, and without the living skin, it would not be habitable. So it's almost, if you like, a paradox that we have to try and get inside.
It's even more remarkable when you think that thin skin, as you said, Mayank, has managed to sustain itself for 4 billion years, perhaps 4 billion years, because that's the history of life on planet Earth. And during that interval of time, there have been huge climatic upheavals. Major intervals of volcanic eruption, asteroid strikes, most recent really big one being 66 million years ago. And yet through all of that thin skin is able to maintain that habitable zone that Jan has been talking about. It's amazing and remarkable to think on that just how durable and resilient the biosphere is. And yet one species at present is really threatening that durability at a very serious level. That species, of course, being us.
Yeah. Let me flip it a bit. If a system relatively small like our planet can produce such a sophisticated biosphere, why is it not possible for the universe of this scale somewhere to have something similar?
Well, possible certainly, because the universe is enormous. When you think of how many stars there are in the galaxy, and then how many galaxies there are, and how many new galaxies have been found just by one photograph, of the James Webb Telescope. There clearly are the possibilities there. But if one takes, now it's quite a large sample, of star systems, and exoplanets, planets beyond Earth, which can be sensed well enough to have some idea, of how big they are, how hot they are, how they orbit around their star systems. And it's clear that most planets are either far too hot or too cold, or have these crazy orbits, around a much less reliable sun. So there is something at least very rare going on here. And I guess one big question for the astronomers, with the James Webb, will be to see, just how rare is this kind of star system? Because then we can begin to approach your question. Once we have this, then you can have that. But it is a kind of double rarity that has got to be fought through here.
Yeah.
But even if you accept that, and I agree with Jan, I mean, I agree with you, Mayank, also. I think there are planets out there with complex biospheres on them. But if you were thinking about per unit of space, then they will be incredibly rare. I mean, by some calculations that I've looked at, the nearest habitable planet might be 17,000 light years away. Well, that's not something that you're going to be able to jump onto your spacecraft and visit in the near future. So again, it still brings back the centrality of the importance of these planets, if we believe that life is something very, very significant in our cosmos.
Your book is extraordinarily detailed, and my compliments on that. And one of the fascinating numbers that jumped out at me was the mass of all living things being some 2.5 trillion tons. That is just 1/10 billionth part of Earth's crust. It's, as you describe it in the book, it's like the skin of an apple. Now that's extraordinary, to think that something that thin is all there is that we call life, and all the certitudes and insanity and lunacy that go with it. It's an absolute wonder to me.
Yes, indeed, and you have this tiny ingredient, like a very small amount of yeast in a very large loaf, and yet it directly it produces much more than its own weight. Let's say the oxygen that sustains us, as well as controlling the other elements of the atmosphere, and as also in its way plants control the landscape of the land, and therefore they control the nature of all the geological strata that have piled up, on Earth. And again, the mass of that is now enormous. So it is it's almost you call it a very slender ghost in a very large and very active machine.
Yeah.
But the mass, as Jan said, is enormous, and that's ultimately predicated on the energy of sun, which is then captured by plants, and then that chemical energy is then transferred through the biosphere. But one of the things we talked about in the book is the way in which humanity has actually reduced the mass of the biosphere quite considerably over a relatively short amount of time. So, over the past 10,000 years or so, it's argued that about half of the mass of the living biosphere has been reduced, half. Now that's very considerable, and indeed that about 10% of that loss may have happened in the last 100 years or so. So not just a big loss, but an accelerating loss, which again talks to the themes of the sustainability of that thin skin of life at the surface of our planet. And it's humans, of course, who've been causing that loss.
That's an astonishingly large drop that you mentioned in 100 years. We'll come to the Anthropocene part in a bit, but I want both of you to visualize a lifeless Earth. And by that, I mean an Earth that never developed life, and not that where life is going to be extinguished. So what is your vision of a lifeless Earth?
I guess the best analog would be our near neighbor, Venus, which has become a Hadean world. It's quite possible that Venus in its early life even developed a biosphere. There was almost certainly water on the surface of Venus, but of course, because it was closer to the sun and warmed up more quickly, the water was vaporized and went into the atmosphere and developed this super greenhouse. So you have to wonder where all of the carbon would be at the surface of planet Earth if it wasn't sequestered into life. And so it's possible, therefore, that an Earth that didn't develop a biosphere might have followed a trajectory not unlike our sister planets, Venus and Mars. That's perhaps my easy vision of what the Earth would have looked like.
It's a reasonable, plausible vision, because if you take the amount of carbon dioxide in the atmosphere in Venus, that is roughly the same as the amount of carbon that has been stored, mostly by life, as coal, oil, gas, limestone, and buried underground, leaving just enough carbon dioxide in the air, to keep us, gently warm, and to keep liquid water, at the surface of Earth. So yes, I mean, and again, it's life that, again, as Mark said, has managed to do that, and managed to do that while the sun has been warming up by something like 20-25%, over that 3-4 billion years. So yes, that's still something I think we find difficult, to comprehend at all.
Right. I've also seen images of Earth without its oceans. If it was just a piece of rock without any oceans, the shape would be very different. It's quite ugly if you take the oceans off. Yes. But I'm sure over a period of a couple of billion years, it would have acquired the same spherical shape that other planets have in our system. Not necessarily, but most likely it would have, even without the ocean.
Probably, again, Mark's vision of Earth as Venus, right, would be similar even more closely, because without water, it's very hard to get the particular Earth-style plate tectonics to work, to actually take 200-kilometer thick slabs of crust and push them inside the Earth, create ocean basins, create mountain chains, create volcanoes and so on. So then we would have, if you like, a Venus-style, planet with simply volcanoes popping up here and there, and creating volcanic line scales without distinct continents, without distinct oceans.
Pardon me if I sound half-baked in my understanding, but would you consider our planet's transition from the inorganic state of geosphere to a biosphere bursting with life as the most defining part of what we have become over the last 3.7 billion years, when microbes began to emerge?
It's certainly a pivotal point, yes, in terms of the genesis of life on planet Earth. But I think, as we talked about earlier, Mayank, that there may be some biospheres out there on other planets that stayed in that relatively simple microbial state. And so I think Jan and I would look at this as a series of major step changes that have occurred in the evolution of the planet. In part, some of those step changes have been essential to maintain the Earth as a habitable place, because, as Jan said, our sun has warmed up by about 25% from its original kind of solar radiation emitted to planet Earth. So certainly the inception of life, I guess, is a critical part of this, and has been hotly debated over the years exactly how that developed, from the kind of Fred Hoyle panspermia ideas to the much more, forgive me, sensible ideas that life actually originated on planet Earth. Because
you're understating stater, I think.
The chemistry of planet Earth is really compatible with developing life, and obviously the fact that the surface is water rich and it's bathed in light. But of course, over that 4 billion years or so of evolution, it's gone from its initial microbial state, which was very simple in terms of the kind of microbes. They were essentially prokaryotic microbes without a membrane-bound nucleus and organelles and things, to a whole series of stages of evolution. The great idea of Lynn Margolis, who obviously collaborated very strongly with James Lovelock on the Gaia hypothesis, that cells cooperated endosymbiotically to make more complex life, and so on and so on and so on. I'm going to pass over to Jan, because Jan can pick this up at endosymbiosis and then can maybe go forward with some of the other big changes. But they're all really important in terms of maintaining the Earth as a habitable place.
Yes. I mean, it used to be thought, that until very recently, indeed, that the Earth, first 3 billion years of life was very boring. Just a few thousand species of microbes. And yet we now know, because of the way that we can pull the genomes of organisms apart, that this microbial world was incredibly diverse in terms of its basic architecture of life, and we as multicellular organisms are just one small part of that. So this complexity started early, and then developed all kinds of powers. One was the power to use more energy. By the beginning of photosynthesis, the production of oxygen. At first a really toxic byproduct that killed most of life off, but the ones that could manage it then learned to tame it, to harness it, to be able to use energy more efficiently, as air-breathing creatures, and then that set the stage for multicellular organisms, that could, have muscles and swim in the sea, and then eventually crawl out onto land and colonize the whole Earth. So yes, as Mark said, a number of major steps. Some of them giant steps, indeed. The appearance of oxygen was one of these giant steps. In the Earth's or the biosphere's evolution.
But as you point out, I think the great oxygenation was initially not life-affirming, right?
Indeed, yes. Oxygen would have been as toxic to most life forms, as chlorine is to us now. A very powerful reactive gas, and so it's estimated that life again was knocked down to something like 5 or 10% of its mass in that. But then very strong selection pressure, so say some microbes that could tolerate and then use oxygen arose, and then the whole story took off, of the oxygenated world.
Right. From 3.7 billion years, I want to jump to 70,000 years ago. You talk about that in the book, where archaeologist Stephen Misson, I'm pronouncing it right, what he calls cognitive fluidity. That's a remarkable concept. The capacity for abstract thought and creativity, as you point out, where it emerged about 70,000 years ago. We are talking a very short lifespan for Earth to go from there to what we are now. It's quite striking.
It's an accelerating process, I think. I mean, our species, Homo sapiens, has a fossil record that goes back 300,000 years. And of course, as a group of human species, we go back nearly 3 million years. But that cognitive fluidity, that idea of behavioral modernity, that people 70,000 years ago, their brains had been reconfigured in a way that meant that they were seeing the world in the way that we do, and were able to form complex societies and develop complex technologies. Is one of the driving mechanisms, I guess, which has led to the world that we see at present. I mean, you could even say, though, that, if there's evidence for cognitive fluidity from 70,000 years ago, perhaps 100,000 years ago, in terms of the tools that people were using, and then, of course, in things like cave art. But even then, the pace of change was incredibly slow for thousands and thousands of years. I mean, people living in the same cave for thousands of years, sitting around the same fire and eating the same stuff and presumably having similar kinds of conversations. And that went on for thousands of years. It's only much, much later that things then really start to accelerate very rapidly over the past 11,000 years.
Right.
Which is, I was thinking Jan was going to segue straight into that then.
Well, yes, that's right. Yes, and of course, the acceleration is continuing now. So in fact, that last 11,000 years, saw, enormous, if you like, human cultural evolution and revolution. The rise and fall of many empires. Times of war, times of peace. And going from the times of, the first farmers to the ancient Egyptians, the Romans, medieval times, and so on. And yet through all of that, the Earth, even a biosphere that was shrinking slowly as deforestation continued across the Earth, still functioned in the same kind of way. I mean, the carbon cycle pretty much, was stayed stable. The nitrogen and phosphorus cycle stayed pretty much stable. Climate stayed pretty much stable, more so than for many thousands of years beforehand. Sea level was extraordinarily stable, the last 3,000 years of that within 10 centimeters, stable, and then, of course, then the next ratcheting up, of this enormous increase, in everything, in human population, the growth of industrialization, energy. Mark can, will explain energy far better than I can here. Globalization, technology, and the growth, of, if you like, this human enterprise to a scale now that rivals, and if you like, presses on rather painfully the rest of the biosphere.
You make an interesting point about how some 12,000 years ago, when the domestication of animals began, humans began to see themselves in control as a species that could lord over all the resources. And you write, and I was quite, again, struck by that, that it could spill over into institutionalized brutality. You can already see that it's already institutionalized brutality all over the planet. Where do you think we are headed now?
So, we talked about cave art depictions a little earlier, and those cave art depictions are evidence, really, that people didn't see themselves as controlling the planet or controlling the wildlife of the planet, that they were looking for some kind of almost spiritual relationship with animals by which they could sense how those animals were thinking and operating, so they could perhaps get a better handle on the way in which they could interrelate to them. And a lot of cave art seems to have that kind of sense in the way in which it's depicted. But once we start to develop civilization, and once we start to domesticate animals and plants, it does appear that relationship changes very markedly. Jan and I use the kind of analogy of, well, we use the example of Roman civilization and the numbers, the colossal numbers of animals and people that were slaughtered in Roman amphitheaters. And that clearly had a very, very distinctive impact on the ecologies of the Near East and the Mediterranean 2,000 years ago. Many animals that were abundant in the landscape disappeared because they were basically hunted to oblivion to appear in these amphitheater shows. In a sense, you could argue that kind of relationship with animals, the way in which we feel that we have the right to control them, has come through very much today in the way in which we mass consume animals. When we talk about, in the book, that the numbers of chickens that we consume on the planet, the 63 billion of them that we munch through every year, and the standing stocks of other animals. There are a billion pigs on this planet. There are a billion cattle. There are a billion sheep. There are a billion goats. That we're actually eating our way through quite quickly every year. That's also part, it's not just about control, but that's also part of the way in which we've massively perturbed the biosphere, that we've now concentrated so much mass in ourselves and the animals and plants that we like to consume, that we've left very little space and increasingly less space for the rest of life on our planet. And that's a fundamentally different relationship from the deep past relationship we had with animals and wildlife.
Jan, you were saying something?
Yes. The statistics, which back up Mark are extraordinary. So if you take, mammals on land, then, in terms of weight, then, we as humans are about 1/3 of that. All the animals we keep, to eat essentially, are about 2/3. And all the wild animals, all of the, elephants and tigers and cheetahs and such like, that's about 2% in terms of weight. So they really have been pushed to the margins. Now, in terms you were suggesting, how is it going to pan out in the future? Well, goodness knows. But one thing that might give a bit of hope is that with increasing self-awareness, of what is going on, the scale of it, and the speed of it, then, other modes of thinking, other attitudes, to the rest of life, might come into play. I think for thousands of years, people thought they were, they were a small, if you like, area of carefully fought for and managed civilization, at the edge of a huge amount of wilderness, and that kind of philosophy, I think, has been dominant. But now, of course, very quickly the tables have been turned. It is now, the humans, and the animals, they keep in various, which are now utterly dominant, and the wilderness is in having, since that state is now here, then, as you said, the question is where there, but at least, that awareness, is becoming more widespread.
It's a perfect segue for me. You also expressed concern about how humans have been homogenizing the planet to the extent that it's degrading both the biodiversity as well as the space which Mark referred to they can exist in. How serious is that?
It's incredibly serious. I mean, there are tens of thousands of translocated species across this planet, and we've been doing that for 20,000 years. But recent work in trying to quantify that has shown that it's an accelerating process, particularly accelerating over the last couple of centuries, and then ever more so from the 1950s onwards. I mean, there are good examples of where you can see this process unfolding extremely well. One that Jan and I have worked on closely is San Francisco Bay. The fauna and flora of San Francisco Bay is wholly reconfigured. Of the order of, in many places, over 90% of the species are introduced, and 90% of the biomass is of introduced species. And many of those species that have arrived, they've arrived from places like East Asia, from Japan, from China, that they're not just introduced, they're invasive, which means that their behavior damages the local ecology. They proliferate to an extent that the indigenous organisms simply cannot compete. And can be extirpated, and in the worst scenario, they can go extinct. Now that's San Francisco Bay, but it's happening even where Jan and I are sitting now. If you look at the river systems around us, the River Trent, which is very near to where Jan is in Nottingham, and its kind of tributary rivers are full of invasive mollusks. So we've got Asian clams in our river system displacing the indigenous mollusks, and that means that this homogenization is reducing the biodiversity of the planet, and it's also reducing the fecundity of individual ecosystems. It's a serious problem for us going forward.
Jan, you wanted to say something, or?
Yes, I can. There are countless examples. In the United States, the zebra mussel, introduced sometime about the 1960s, has now, taken over waterways over half the continent. Pretty much. It's been an astonishing, spread, of these things, which they simply elbow out, the local mollusks. Now, there are many, this kind of state, has been, you mentioned the Anthropocene. It's also been called the Homogenocene, for this very reason. Again, quite how it's going to pan out, is not, something that people should really think on. Because it is quite new to the history of the Earth. There have been local, if you like, invasions. Let's say when continents joined, like when North and South America joined, some few million years ago. Then species, went, north and south and so on, and but this has never happened planet-wide in the way that it has done now. And one thing to think about in this is that as other changes take place to the planet, such as, let's say, global warming, we then have to try and put another piece of the jigsaw puzzle together, is to say, how will these newly arrived species cope with the warmer temperatures, and the higher sea levels that we're going to have, is that going to, if you like, increase the health of local ecosystems or decrease the health? So it is a very new and complicated puzzle. We have to try and disentangle.
Just the last couple of questions. One is, the debate now seems to be resting on whether the human race can become responsible stewards, I think you two mentioned that, of this planet, or become even more destructive exploiters of it. Where do you think we are headed? From the way you're describing, we are not in the right direction at all.
I think kind of international organizations are not responding at the pace that they need to. I think that the problem is clear. I mean, if ever we needed it, the problem of climate change is so obvious this year. In that, it's a much warmer planet and it's having major regional impacts. But we've known this was going to happen probably for 50 years, since people started discussing climate change in the 1970s, but it's moved ever so slowly. So at the political level, I think it needs a much stronger understanding that we need to leave large areas of the planet wild if we're going to maintain the biodiversity of our planet over the short time frame. Otherwise, as we've said in the book, we'll end up in a mass extinction very, very shortly, in a few decades. The political will is not there yet, but the will amongst young people that we've been teaching is really strong now. We see a really massive societal change, I think, and the young people really want change to happen very, very quickly. And I think that's where my faith, and I think Jan's faith, is in the next generation really making changes that are very, very significant.
Yes, I think indeed it is. There is a generational change, that we can see in let's say the students coming through our courses, and again, this awareness and ways of expressing it. We work closely with a very good historian friend and colleague, Julie Aidney Thomas, who makes the point this is not a crisis. A crisis being something that you can solve, perhaps by technological means. It's a predicament. It is a new kind of state, which will have to be lived with, coped with, as well and as decently as possible, and that will therefore need, as Mark said, new kinds of politics, new priorities, new patterns of investment, very simple day-by-day things to cope with. And again, hopefully, as this becomes ever more clear, as it is doing, then that will help, the forces that are trying to, in effect, keep life going.
Now that the human destructiveness is a fait accompli, as we just discussed, I want to come to the final question about Anthropocene. I sent you both that study which said that the Trinity test, its spread was far wider than it was expected or believed then. It's essentially global in their judgment. Do you think that might become the marker, not necessarily the Trinity test, but that period, 1950s, early 1950s period, become the marker for the rise of the Anthropocene?
Go on, Jan.
Okay. Yes. Well, in a short word, yes. I mean, it is not at all certain, that the Anthropocene, will become formalized as part of the geological timescale, because for many geologists, even if they are aware of something of the scale and the speed of the changes and the irreversibility of the changes that have taken place, for geologists thinking used to millions of years, then an epoch just 70 years long, is still very hard to wrap around one's head. But the effort that is being made to try and have the Anthropocene formalized in this way, it is this radioactive debris, from these tests, which, as you said, started in 1945 and went wide, and then increased and went even more global from the early 1950s, with a very big thermonuclear H-bomb tests. And those tests, if you like, they're not, compared with the effects of, burning hydrocarbons and urbanization, they had little direct effect, upon the biosphere, at least so far, thankfully, in that, though they've been terribly destructive, locally, but they are a very good time marker. And the Anthropocene, is a geological time unit, and it is precisely that. It has to be defined by an event which is more or less synchronous around the world. And the best candidate for that, is this very rapid spread, of radioactive debris everywhere. We have it in our bodies, even, from that time, from the Antarctic to the bottom of the ocean, to the tops of mountains, to the bottoms of lake beds everywhere. It's that signal is there, to help us navigate, through time and history and process.
If I could add one thing to that as well, I think, the Anthropocene and its time signature is very clear to us as geologists. But I think part of the solution to the problems that we're confronted with the Anthropocene is an understanding that not all of humanity has caused this. And Jan and I and Julia Thomas, who we talked about earlier, have kind of tried to argue this, and some of the things that we've written, and many other people have obviously talked about this, is that it is those of us in wealthy Western countries that have largely caused the Anthropocene. There are many people in the world that have made very little contribution to this at all, but still have, very difficult lifestyles. I think part of the discussion about how we solve the problems of the Anthropocene is how we deal with those disparities of wealth and power in the coming 21st century.
That's a politically fraught observation that you made, and I'm glad you made it, because only a neutral scientist would be able to say it. Otherwise, I think there is still reluctance to recognize that obvious fact.
Yes, indeed. I mean, the one, again, if you like, privilege that we have as scientists is to be able to try and look at things as dispassionately as possible, and the old Enlightenment idea of evidence-based science, and it's clear that in trying to get at the driving forces of the Anthropocene, the driving forces to the change of the biosphere, then there are very great complexities and disparities of if you like, power of agency of making these changes between different groups of humans. And there is further complexity because, of course, technology is now a large part of this, and therefore you have the control we have or don't have upon technology, as again another driving force. So it's a terrifically complex problem that does involve these tricky social and political questions, but also range far wider than that, into the idea that that's been made of the technosphere, where humans are part of it. But not really controlling or driving it, but caught up in it, with all of their political institutions. So I think, certainly much to work on, to think on, as we try and navigate, the years ahead.
A question that I forgot to ask was, as you're paleontologists, as your discipline, both of you, and yet
yes,
the book is so richly detailed in subjects which are not paleontology. How was that challenge?
Wonderful, I think, because one of the great things of writing these kinds of books is that it challenges your knowledge base and encourages you, in fact, demands of you to go and read much more broadly than you normally would. So I always find these experiences, which I've really enjoyed with Jan, because we've done several of these over the years, as really enriching in terms of your own understanding of the problems.
Yes, I mean it's we're all out of our depth now. I mean that's in that, and here we were helped greatly by working with Anne-Sophie Milon, who not only illustrated the book, provided her own artistic reimaginings of what we're saying, but as a humanist, she added far more to the book. She could point out, where we were heading towards a cliff edge, and guiding us towards, more stable ground where we could develop our ideas, on that. So it's very much a joint effort in that.
No, this is fascinating. I was riveted by this conversation as well as the book. My congratulations to both of you. I hope you thought it was worthwhile to engage in this conversation.
Very much so.
It's been great.
Thank you.
Yeah.